The basic architecture of CQRS is that you've got MVC, or some kind of web app in this case, and you've got something called a command. Command is a message. And MVC, the user will use MVC, create a command. The command will go in something called a queue. What's a queue? Well, it's first in, first out. And then what you'll have is you'll have a bunch of workers, depending on what you want to scale, and they will all look at this queue and consider that as a list of items they can do. Now, what a worker will do is it will go and it will find something called a handler. A handler is an object in code that tells that worker what to do when they get that command. And the handler for commands will generally involve loading what's called a aggregate root and calling a behavior on that aggregate root. I'm going to draw this. Let's try this. It's going to invoke. So it's going to invoke that aggregate root, something like, imagine it's post order or change name or something. Something's going to happen. This command, basically the command turns into an invocation on the aggregate root. It's not HGG root, it's aggregate root. Okay. Now, what that invocation, so if we're still inside the handler here, the invocation will result in something called events. Events. Maybe just one event. But anyway, what events are is they'll represent that this actually happened. The command here says, please do this. The queue represents that command. The worker represents an attempt. The worker represents an attempt to please do it. And the aggregate root represents the business logic, which says, well, let's see if you can really do this or not. Let's see if this is actually a good idea to do this. See if I'll let you do this. And the events represent the fact that yes, this did happen. Okay, so that's kind of how it works. But so these things here are just kind of infrastructure. So, all right. So that's only part of it. What happens to these events? Well, these events, when the handler's done, they will get dispatched to another queue. Another queue. But this one is for events. This one was for commands. And this one's for events. So my question is, or my observation at this point, is you might not have noticed this, but there is a one-to-one relationship here between handlers and the message. So this command, the command and the handler have a one-to-one relationship. So the command to change the name has a one-to-one relationship with the handler. Okay? All right, so what about this event queue now? Well, let's draw it. The event queue is going to have events in it, obviously. And there are going to be workers, right? And the workers are all pointing to this queue, just like they were before. But there's a difference. Let me try and draw this very similarly. We're going to now go to a handler. So the worker will result in a handler. And the handler will say, okay, whereas before we had this aggregate root and invoking a behavior on the aggregate root, but this time around, there's several things we could do with an event. Let me just jot them here. We could update a view, or we could call a saga. And these are both, n and n. This is plural. This is plural. There's no telling as to how many handlers there are. So here we have a 1 to n relationship. We don't know how many handlers there are. So we have a problem. If we loop through the handlers, say we do that. Say we got 6 handlers, okay? Let's say that let's say our worker, let's do this. Let's put the worker on here. Let's say the worker has 6 handlers. So it's going to loop through the handlers. 1, it's going to pass. 2, it's going to pass. 3, boom, something goes wrong. What do we do? Well, the event, the message, if we go here, when this happens, when we're done, where's the done place? When we're done at this particular point here, then what we can do is we can then dequeue the command, right? So the original command comes off the queue. So we don't want to handle that command more than once, right? But at this point in time, we can't dequeue because we still have 4 and 5 and 6 that we still want to do. So how are we going to get to those? And if we try over again, if we want to start over, how do we get? We're going to run 1 and 2 again. We're going to repeat these. These are going to be repeated. So looping the handler is not a good idea. The worker can't loop through all the handlers. There's that 1 to n relationship, and we can have all these complicated solutions, and there's ways we can solve this that are not very elegant, and they make it complicated. So what I propose is, instead of that, what we can do is there are 3 queues I have in mind for my business needs. One is for read models, or views. The other is for sagas, long-running business processes. I don't know what that was. Try again. And the other was for web responses. I got MVC is waiting for some things. Now, this web responses here does not need any workers. No workers needed for that. That's just a message. You don't do anything with those. But read models and sagas, you do. So what my worker is going to do in this case is it's going to act as a multiplexer. Multiplexer. My friend Ryan Hatch came up with that term. So this worker is actually, just a sec here. All right, so the multiplexer, what it's going to do is it's going to take in the message or the event, and it's going to find handlers, and those handlers, excuse me, it's going to decide what kind of handlers they are. Are they a read model handler? Are they a saga handler? It's going to make that decision. And it's also going to write that again. It's also going to decide if I should respond. Maybe I should send a response also. So it's going to do 2 things. It's going to find handlers. It's going to find handlers, which could push it up to one of these 2 queues. These are queues. I should put a queue on there. It's going to find handlers, and if there are handlers, it's going to put it on the appropriate queue. But this, what's interesting here is, given 6, here is a 1-to-1 relationship between the handler and the original message. So let's imagine we got our workers here, running out of space, but let's imagine the workers are there, and we'll make the workers yellow just so that this looks pretty. The workers will be, of course, interested in these things. They'll be monitoring all the queues, right? But what's interesting here is when you find the handler, you will include the handler here. So include handler. So if you have to find the handler, and let's say we said before 6, right? Well, let's say that one of these is web responses are usually handlers. Okay, let's say if 2 of these are for let's go with my eraser. Say if 2 of these are for sagas and 4 of these are for read models. Well, it's going to send 6 messages total based upon the handlers, and if it should respond, then here it would just probably, I don't know, it's probably 1. But if it's going to find the handlers, then what it's going to do is it's going to include the handler, which handler to use, in the message, and it'll send, it'll multiplex it. So we started out with one message. We started out with one message here. Let's see here. We started out with one message, but in the end, we ended up with 6 or 7 messages. We ended up with 4 for read models, 2 for sagas, and 1 for, that's the wrong color, 1 for the web response. Now, this looks complicated, but it is an elegant solution because it allows the queues, it leverages the existing behavior of queues to have poison messages, to allow retries, and it'll help us scale out the work. So the gist of it is, here's CQRS in a nutshell. In a nutshell, here's CQRS. We start out with MVC, then MVC makes a command, then the command goes on the queue gets picked up by one of these workers, or the command in the queue gets picked up by one of these workers. The worker goes and finds a handler. There's a one-to-one relationship between the handler and the command. The command handler will go find an aggregate root. It will invoke something on the aggregate root. This will result in events, and the events will go into the queue, the event queue. This is the view for commands. This is the queue for events. See if I can rewind all these guys. All right, that's the command side, and we resulted in events. Now that we have events, we have a bunch of workers who are ready to do something. So what they're going to do, the problem is we've got a one-to-n relationship between events and handlers. So what the worker's going to do is it's going to become a multiplexer. It's going to find all the handlers available for that message on the event queue. It's going to split that up. It's going to send a new message that includes the original message and the handler to possibly here or here, or it might include a response here. So, and then we have a pool of workers who will be able to invoke the handler from one of those two queues. That's it in a nutshell. Oh, and of course, when this happens, when we've done this, and this, and we're all done, the net result is that we DQ from here. So the event does not sit around and happen and get handled again by another multiplexing worker. So I hope that captures it.